All right, let's talk about something that drives pretty much everyone crazy, getting stuck in a contact center maze. We're going to show you how to build a way smarter, way more responsive system by plugging AWS Lambda right into your Amazon Connect flows. Let's get into it. So picture this. You're a huge health insurance company. You've got thousands of members calling every single day. Some have simple questions, some have urgent problems. But right now, they all get dumped into the same generic queue. This leads to endless transfers, super long wait times, and honestly, it's just a terrible experience that really damages trust. So here's our plan. We're going to build a solution from the ground up. First, we'll look at the technical blueprint, the architecture. Then we'll use that blueprint to solve 3 very real problems. And finally, we'll talk about the #1 reason this whole approach is a game changer, not just for features, but for how you actually build and maintain your system. Okay, here's the big idea. Think of Amazon Connect as your contact center's powerful, super reliable switchboard. It's amazing at routing calls from point A to point B. But what happens when you plug in AWS Lambda? Well, you essentially give that switchboard a brain. Lambda lets Connect reach outside of itself, query other systems like your CRM or a database, and make intelligent decisions before a human ever gets involved. All right, let's pop the hood and get into the mechanics. For all you developers out there, this is where we're going to look at the architecture and see exactly how the data flows to make all this intelligence happen. So take a look at this diagram. What's great is how simple it is, really. Over on the left, you've got Amazon Connect, where the call flow lives. In that flow, you used a special block to invoke or, trigger an AWS Lambda function. That function is basically a tiny, dedicated microservice. It grabs info from Connect, shoots off a query to an external data source, maybe a fast key-value store like DynamoDB, gets an answer, and zips it right back to Connect. Let's trace that data path step by step. So 1, it all starts with the invoke AWS Lambda function block in your Connect flow. It sends some key info, like the caller's phone number, over to Lambda. 2, Lambda takes that phone number and immediately uses it to run a query against your database. It's asking, hey, what do we know about this person? 3, the database finds the record and sends the results straight back to Lambda. And finally, step 4, Lambda formats that data into something Connect can use and sends it back. And just like that, your contact flow isn't blind anymore. It has context. Okay, so that's the theory. Now let's make it real. We're going to follow a developer at our fictional health insurance company, we'll call them AnyInsure, as she starts tackling some of their biggest contact center headaches with this exact blueprint. AnyInsure's first big problem is a classic one. A member with an open, active claim calls in. But instead of getting sent to a specialist who actually knows their case, they end up with a Tier 1 agent who has to look everything up from scratch and then transfer them anyway. It's a huge waste of time and super frustrating for the member. So here's the fix. The developer spins up a Lambda function. It takes the caller's phone number, uses it to search their CRM, and looks for any open cases. If it finds one, it just grabs 3 key details: the member's name, their case ID, and a quick summary of the issue. And this is the payoff. Lambda returns a simple JSON object back to Connect. You can think of this as the data contract between them. Now, the logic in the Connect flow becomes incredibly simple. All it has to do is check one thing: does a case ID exist in the data I just got back? If it does, bingo, you've just programmatically confirmed this person has an open issue. And the result? Now the system can greet the member by name, maybe even say, I see you're calling about your open case, and then route them directly to the right specialist team. No more transfers, lower handle times, and a much, much happier member. Problem solved. Okay, next problem. AnyInsure noticed that a huge chunk of their calls, maybe 20%, were for really simple, repetitive tasks, like prepaying for lab tests. This was tying up agents who could have been handling way more complex stuff. It's a perfect candidate for automation. So here, Lambda's role gets even cooler. You bring in an Amazon Lexbot, that's AWS's conversational AI service, to actually capture the payment details from the member. Then the Connect flow just hands those details over to a Lambda function, which securely connects to AnyInsure's payment gateway and processes the whole transaction. And the outcome here is a total win-win. Members can now make these payments whenever they want, 24/7, without ever waiting to talk to a person. And the contact center just freed up a massive amount of agent time for issues that actually require a human touch. All right, one last challenge, and this one's all about delivering a premium experience. AnyInsure has these high-value French-speaking members, but they kept getting routed to the default English-speaking queue. This meant an immediate transfer and, honestly, a really bad first impression for their best customers. The solution for this is so simple, it's beautiful. A new Lambda function is created to do just one thing: take the caller's ID, dip into a database, and pull out two little pieces of information: their membership status and their preferred language. The function sends that info back as a simple key-value map, which Amazon Connect can read instantly. And now, the logic in the flow is dead simple. You just ask, is membership status premium and is preferred language French? If both are true, you send them straight to the premium French-speaking queue. And just like that, the problem is gone. No more wrong routing, no more frustrating first contact transfers for their most valuable members. It's a direct, measurable improvement to their customer satisfaction. So, if we pull back from these specific examples, what's the big takeaway here for you as a developer? Why is this architectural pattern so important? Well, it really comes down to this. When you use Lambda to inject data and logic into your flows, you're fundamentally upgrading what your contact center can do. You're moving from a purely reactive system to a proactive one. You can personalize interactions, you can enable self-service, and you can reduce customer effort because you already know what they need before they even ask. But, beyond all the cool customer-facing stuff, here's the most critical point for anyone who has to actually maintain these systems. This approach makes your logic modular. Instead of having one giant monster contact flow that's impossible to debug, you break out specific pieces of business logic into small, individual, and most importantly, testable Lambda functions. This makes the whole system so much easier to build, to update, and to manage over the long run. So by connecting this data-driven brain to your contact center's switchboard, you just unlock this whole new level of intelligence and efficiency. You can start anticipating what your customers need instead of just reacting to what they ask for.
All right, if you're a developer, this one is for you. We're doing a deep dive, a technical look at how you integrate Amazon Connect with AWS Lambda. We're going to see exactly how you connect a cloud contact center with all the power of serverless compute. Let's jump in.
So, let me ask you something. Have you ever called a company, and the second they pick up, they greet you by name, before you've even said a word? It feels kind of magical, right? Well, it's not magic, it's just some really smart tech. And we're about to pull back the curtain and show you exactly how it works. The secret sauce here is a really powerful serverless architecture. Think of it as a three-part system. You've got Amazon Connect handling the actual call, an AWS Lambda function acting as the brains of the operation, and then it connects to some data source, like your CRM, to pull that customer info in real time. And using serverless here is absolutely key because it is just so efficient. It scales up and down automatically no matter your call volume, and you literally only pay for the few milliseconds of compute time it takes to run your code for each call. So here's what we're going to cover. We'll start with the high-level architecture, the 30,000-foot view. Then we'll zoom right into the data contract, the input event your Lambda gets. From there, we'll look at the code itself, how you need to format the response so Connect can understand it, and finally, we'll walk through the super important step of testing your function before it ever sees the light of day.
Okay, first up, let's look at the big picture. How do all these different services actually talk to each other to create that seamless, personalized experience?
The whole thing is this really clean 5-step dance. So a call comes into Amazon Connect, and boom, it kicks off a contact flow. That flow gets to a certain point where it triggers our Lambda function. The Lambda then reaches out to some other system, say a CRM, using the caller's phone number to look them up. The CRM sends that customer info back to Lambda, and then Lambda immediately passes that data right back into the Amazon Connect flow. Simple as that. And here's the number that every single developer building this needs to burn into their brain: 8 seconds. That is the absolute hard-coded maximum timeout for this whole process. If your Lambda function and whatever data source it's calling take any longer than 8 seconds, the integration fails, period. So performance is everything here.
All right, so we've got the flow down. Now let's get into the weeds and talk about the data itself. For a developer, the first thing you have to master is the input event. This is your data contract between Amazon Connect and your Lambda function.
You see, when Amazon Connect invokes your function, it doesn't just ping it blindly. It passes along this really detailed JSON object, which we call the event. And this object, it's your lifeline. It contains all the context, everything you need to know about the call that is happening right now.
Now, if we peek inside that event object, you'll find everything you need under event.details. There are two parts here that are super important. Contacts data has all the built-in stuff, like the caller's phone number. But the real power, the real flexibility, comes from parameters. This lets you pass in your own custom key value pairs directly from the contact flow.
So where do these custom parameters come from? Well, you define them yourself, right inside the Amazon Connect user interface. When you're building your flow, you get to this Invoke AWS Lambda function block, and right there you can define these key value pairs. And whatever you configure in this UI is exactly what shows up in that parameters object in your code. It's a direct connection.
Okay, we've got our data, we know where it's coming from. Now for the fun part, writing the code that actually does something with it. Let's dig into the handler logic.
The front door to any Lambda function is the handler. If you're using Node.js, this is a function that gets a few arguments, like event, context, and callback. But for what we're doing, the one we really truly care about is that first one, the event object. That's our primary input. So let's walk through what a typical handler does. First, you'll grab those parameters that you passed in from Connect. A really common and clean pattern is to then use a switch statement based on one of those parameters. Maybe you have one called operation, and that lets you route the request to the right piece of your business logic, whether that's checking a balance or locking a credit card. After your logic runs, you just build a simple response object. And finally, you use that callback function to send the response right back to Amazon Connect. And you're done.
Okay, so we've covered what data comes in, but what you send out is just as critical. Your Lambda function can't just return whatever it feels like. It has to follow a specific return contract that Amazon Connect can actually understand.
And you basically have two choices, two flavors for your response format. And you set this up back in your Connect flow. The first one is called string map. Just think of it as a flat object, a simple dictionary of key value pairs. It's perfect for returning simple data. Your second option is JSON, which, as you'd expect, lets you return more complex, nested data structures if you need to send back richer information. And you can see exactly what that looks like in the code. The string map is totally flat, just one level deep. The JSON example, on the other hand, has a nested balance object inside of it. The big takeaway here is just to make sure that the format you're outputting in your code matches the setting you picked back in the Amazon Connect block. If they don't line up, it's just not going to work. All right, your code is written, your response is perfectly formatted. You are almost there, but please don't deploy it yet. The final, and you could argue the most important step, is testing. So let's see how you can do this right inside the AWS console.
The Lambda console has this awesome built-in testing tool. You just go to the Test tab for your function and create a new test event. And here's the best part. AWS gives you a template specifically for Amazon Connect called Connect-Contact-Flow-Event. You just select that, customize the parameters section to simulate different kinds of calls, save it, and run the test. You'll see the exact output and all the logs. It's fantastic for debugging.
You know, this brings up a really crucial point that often gets overlooked. This whole process isn't just a developer sitting in a corner banging out code. It has to be a team sport. The developers writing the Lambda function need to be in constant collaboration with the experienced designers who are building the contact flow. You have to define that data contract together, both the inputs and the outputs, before anyone writes a single line of code.
All right, so if you're using AWS Lambda with Amazon Connect, you already know just how powerful that combination can be. But let's be honest, there's a huge leap from a basic Hello World function to a truly production-ready integration. In this explainer, we are going to bridge that exact gap. We're diving into the best practices for building functions that are resilient, scalable, and way easier to maintain for your contact center.
So let's kick things off with a scenario that might give you a little bit of anxiety. You've got a critical Lambda function running in a live Amazon Connect flow. You know, maybe it's pulling crucial customer data or handling payments, and you need to deploy an update. What's your next move?
If your first thought is to just upload the new code and kind of cross your fingers, well, you know how nerve-wracking that can be. By default, Amazon Connect just uses the latest version of your function. That means one tiny bug goes live instantly, potentially affecting every single customer hitting that flow. And that right there is the core problem we're here to solve today.
So here's our game plan. First, we're going to talk about decoupling your configuration from your code. Then, we'll get into safe deployment strategies to totally eliminate that risk. After that, we'll master function permissions. And finally, we'll see how it all comes together for a really resilient result. Okay, first up, let's tackle a really foundational best practice, getting all those configuration details out of your actual code. I'm telling you, this is step one for creating functions that are flexible, reusable, and so much easier to manage across different environments, like dev, staging, and prod. The tool for the job here is Lambda environment variables. Just think of them as settings that live completely outside your code. So instead of hard-coding something like a database name or an API endpoint, you just store it as a variable. This is absolutely key to making your function generic and reusable.
So what kind of stuff should you put in there? Well, the perfect candidates are any values that change between your environments. Things like the Amazon Connect instance ID, maybe some S3 bucket names, specific queue or flow identifiers for transfers, or even operational stuff like how many times you want to retry an API call. And actually getting to them in your code is super straightforward. In Python, for example, you just use the standard OS library. You just import it and reference os.environ with whatever variable name you set in the Lambda console. It's clean, it's simple, and it creates that perfect separation between your logic and your configuration.
Okay, so our configuration is now nicely decoupled. Let's get back to that high-stakes deployment problem. We need a solid mechanism that gives us complete control over which version of our code is live at any given moment.
Just look at the contrast here. It's night and day. On the left, you've got the default behavior that causes all the stress. Your connect flow points directly to the $latest version of the code, so any change is instantly live. Super risky. But on the right, with an alias, everything changes. Connect now points to a stable, named pointer, and you, and only you, decide when to move that pointer to a new version. So what exactly is a Lambda alias? Well, it's really just a pointer. When you're happy with your $latest code, you publish it. That creates a numbered, unchangeable snapshot. We'll call it version 1. Then you create an alias, maybe you call it prod, and you point it to version 1. Now here's the crucial part. Your Amazon Connect flow is now configured to invoke the prod alias ARN, not the function's main ARN.
This creates an incredibly safe workflow. You can develop and test away on the $latest version, totally isolated from production traffic. When you're ready, you publish a brand new, unchangeable version, let's say version 2. Then, with a single action, you repoint your prod alias to this new version. The contact flow itself never changes, there's zero downtime, and hey, if something goes wrong, you can roll back to version 1 in just a few seconds.
And this leads to an even more powerful technique, weighted aliases. You can actually point your prod alias to two different versions at the same time and split the traffic between them. So for example, you could send just 10% of your live traffic to the new version to see how it performs. This is a canary release before you roll it out to everyone. This is how you do professional, low-risk deployment.
All right, we've got our configuration separated and our deployment strategy is locked down. The final piece of this puzzle is permissions. We have to explicitly and securely grant Amazon Connect the ability to invoke our function. And this gets really interesting when your resources are in different AWS regions.
So when your Lambda and your Connect instance are in the same AWS region, life is simple. You just pick the function in the Connect console and it handles all the permissions for you automatically. But if they're in different regions, maybe for compliance or resilience, the process is a bit more hands-on. You have to use an API call and attach a very specific resource-based IAM policy directly to your function.
Now I know IAM policies can look a little intimidating, but they really break down into 4 simple parts. You've got the principal, which is just who is being given permission. For us, that's the Amazon Connect service. Then there's the action, which is what it can do, invoke the function. The resource is the specific Lambda function it's allowed to touch. And most importantly, you've got the condition. This is what locks it all down, making absolutely sure that only your specific Amazon Connect instance can trigger this function.
And you don't have to just hope the policy is correct. You can verify it yourself using the AWS command line interface. Just run this AWS Lambda get policy command, and notice how we're specifying not just the function name, but the alias /prod. This gives you a crystal clear view of exactly who has permission to invoke that specific production-safe version of your function.
So let's bring all 3 of these practices together. What does our Amazon Connect integration really look like now that we've put in environment variables, aliases, and the right permissions?
Well, here are the key takeaways.
First, we decouple our functions with environment variables. This makes them reusable and a breeze to manage. Second, we take complete control of our deployments using Lambda aliases, which eliminates risk and lets us do cool things like canary releases. And third, we secure our functions with those explicit, resource-based IAM policies, guaranteeing only our Connect instance can invoke them.
By putting these three best practices together, you really move away from those risky, hard-to-maintain functions and toward a truly professional, resilient, and scalable serverless architecture for your contact center. You've minimized risk, you've boosted your operational agility, so really the only question left is, what are you going to build next?